In this episode of the GWM tutorial series, we will continue our look at basic features and look at interpreting GWM output. And we will once again focus on the dewater problem. Once again, here's the dewater problem. We have 7 candidate well locations indicated by the circles. We have 10 head constraint locations indicated by the stars. And the objective is to minimize the total pumping rate amongst all the wells while maintaining heads at all the starred locations below 50 feet. And as you can see from the boundary conditions of 80 feet on the left side, 60 feet on the right side, we would expect the non-pumping heads to be around 70 feet. In previous episodes, we've gone through the input to this problem, and now we'll take a look at the output. And here it is. This is written to a file that has been named dewater.gwm out, and we'll just scroll through it and see what's in it. So first we note that the version of GWM that we're using, 1.5.2, was built from ModFlow LGR version 2. And this reminds us that GWM 2005 is intimately connected with a particular version of ModFlow. As we scroll down, we see that the input is being echoed to the screen. So here first is the decvar file. And these are the decision variables. Here they are, their names. They're all withdrawal variables. There are certain layer, row, column locations, and they're all available in stress period 1. This is a steady state problem. We move on to the objective function, a file, and GWM prints out for us the actual form of the objective, which is to minimize 1 times Q1 plus 1 times Q2, etc. Now to the variable constraints file, the varcon file. Here are the flow rate variables and their minimum and maximum values. Onto the head constraints file. We have 10 head constraints located at these 10 locations, 10 layer, row, column locations, and we're requiring that the heads be less than or equal to the right-hand side of 50 feet in stress period 1, again a steady state problem. Solution file is then read and echoed, and it shows that we've chosen the LP. We'll conduct a single iteration of the linear problem, and other information is output. You'll note that going through here that GWM keeps track of the amount of memory that is allocated for the problem. And this is a very small problem, of course, but this may be of interest for very large problems. We then begin the solution algorithm. And the first step in the solution algorithm is to run a base flow simulation. And GWM reports at that juncture, after that run, the status of those constraints, status of all constraints. So the headbound constraints are listed here. None of them are met, and listed also is the distance to the right-hand side. In other words, we want the heads to be 50. As I suggested at the beginning of this episode, the heads are probably around 70, and we see the difference, the distance between the current heads, the non-pumping heads, and the target heads to be around 20, 22, 18, and so on. So that all makes sense. Here we go. So these are not met. The next step is to calculate the response matrix, and here we go with the repeated simulation of the problem. We perturb flow variable 1. We use a perturbation value of minus 10,000, which would be 1/2 of the upper bound as specified by the delta variable in the solution file. And we do that with each one of the variables. So each of these perturbations implies a run of the simulation model. We now move to solving the linear program. A feasible solution is found and an optimal solution is found. Now we move on to the actual solution. And here is the optimal solution, and a number of things are reported at this juncture. First, we have the optimal flow rates. So here are our 7 variables, and here are the withdrawal rates that have been selected. Largest withdrawal is at location 1, and at location 7. Location 2 and 4 have somewhat smaller withdrawals. Notably, locations 3, 5, and 6 have no withdrawals at all. Total withdrawal is shown, and in this case, since the objective coefficients are 1, all the objective terms are of the same increment. You'll notice that the objective contribution to the objective is a factor of 3, larger than the withdrawal rate. And this is because the length of the stress period for this problem is 1,000 days. And so these withdrawal rates are multiplied by that duration and by the coefficient of 1 to arrive at the final contribution to the objective. We'll move on to the constraints. What we find is that of the 10 constraint locations, only 4 of them are binding. And what this means is that those are locations where the head is exactly 50. And what we will find is that at the other locations, the other constraint locations, the head is below 50, less than 50. So the constraint is more than satisfied. This is a reminder that the optimization problem does not seek to set the constraints as equalities, but as inequalities at many locations. Returning to the problem itself, and referring back to the particular row and column locations of the various constraints, we find that the binding constraints are in this corner, in this corner, in this corner, and down here. In other words, the head at all other locations wind up being less than 50. Also, the optimal pumpings is at location 1, 2, 4, and 7. Wells 3, 5, and 6 were determined to be unnecessary. Returning now to the output file, we see something called shadow prices and range analysis. These are advanced topics and will be discussed in a future episode. Skipping ahead to the final flow process simulation, GWM uses the optimal flow rate variables to do a final run of the simulation. The reason for this is that the optimization problem was solved using the response matrix, which is an approximation of the true response. So here we have the results of the constraints using the optimal flow rate variables run back through the simulation model. And we find that the simulated at locations 1, 3, 6, and 10, the head is in fact 50 and is binding. And in all other locations, the head is less than 50, sometimes several feet less than 50. In the last column, we see the difference between the specified constraint and the simulated value. And we see that in the case of a so-called binding constraint, there may still be a difference of a few very small number of digits, 10 to the minus 9, 10 to the minus 10 difference in the computed heads. It should be noted that, again, that at the same time that we have the GWM output file, we have the usual modflow listing file, and all of the information from that would be available for the user.